is a Coloma, the Coloma Basin, is a granite that's about 143 million years old. And then you go down here south of El Dorado, the Somerset area, this is a massive intrusion of granite. And that granite intruded in that big area. This is 133 million years old. So there's your heat engines, heating up hot water, acidic solution going through these rocks, dissolving the gold, and then concentrating it in these fault zones. So if you look at the geologic maps of these areas, and you look at the real rich hard rock mines, very close to that is an igneous intrusion. And that tells you, hey, that, that's an area that you really need to look at as far as gold. So this shows the main three intrusive bodies here in our area and the ages of these. The gold in the mother lode was placed about an average of about 150 million years ago. So that was the age at which the gold came up through and precipitated out in these particular rocks. In the granite batholith, as you're looking at it in here, this stipple, this is the western metamorphic belt, and then this is then with his chicken scratches all over it, is the granite. And these dark blobs in here are called roof pendants. Roof pendants are part of the old Paleozoic ocean floor and volcanic rocks that were not completely assimilated when the granite was pushed up into it. They're like little isolated islands of old seafloor sediments. And if this room were a batholith, a major mass of granite, the light fixtures and the things hanging down out of the ceiling into the room would be akin to the roof pendants on the outer edges of a batholith in that particular area. So these bark blobs are all over the Sierras, and very commonly the outline and the edge of these things are quite heavily mineralized as you look at it. So these were areas. This is a geologic map of the roof pendants west of Convict Lake. Convict Lake over here, this is Highway 395 on the east side of the Sierras, and this is the crest out of both Mount Morris and the crest. All these different rocks in here are roof pendants. If you look at it in here, there's a main fault and a contact zone in here. This is granite, right in this area here. And all these other superly fault zone and crumped up, there's Dos Equis, and there's, Bud Light, and there's Miller's Highlight in those particular cases there. So you've got these older folded rocks in those particular areas. This is a shot taken from the entrance to Convict Lake on the east side. And if you have a chance to get down there, this is absolutely spectacular geology. It rivals any place in the world, literally. This is Mount Morrison, the roof pendant looking southwest from Convict Lake. All these different letters in here are symbols of the different formations that are in there. And so you see the crust of the Sierras is not all completely granite, but there are other rocks that were not completed. If you look at the east side of the Sierras, there's a major fault that runs right through here. And this picture is taken of Mona Lake from Conway Summit. Conway Summit is overlooking the Mona Lake Basin. The Mona craters are a series of craters, volcanic craters, that are located right in here. They go from Pond Crater right next to the lake all the way down about 20 miles down to the south. This is the oldest lake in North America, age-wise, but it has the youngest volcanics. These volcanic islands in the lake and down in here are less than 500 years old. So this is active volcanic material, and this is an active fault zone in this area here. There are many resources of geology for the layman, written for the layman. There's a roadside geology of northern and central California by ALT, A-L-T, and this is put out as a paperback from Mountain Dress. And you can get that at the Bell Tower downtown at the little bookstore there. You can get it. Go to Amazon and go Roadside Geology of Northern and Central California. And these are the books. This is a map of Highway 49 in this particular area here. And it shows this is Placerville in the northern part here, all the way down to Mariposa on the south. And this shows Highway 49, now the main central part of the Molo. All these little hatchers and squiggles and things in there are the different geologic formations. You can take this book with you in the car. As you're driving along, you get down there, Copperopolis, you can look and see. You get in there over on the hills, it'll tell you what the the geology is like and that type of thing. These are highly recommended. They're not that big of an investment, and it's something you can throw in the glove compartment of your car and carry with you. And this goes from the Oregon border all the way south to Owens Valley or Death Valley on the east side of the Sierras and go over the edge of the foothills. So the source of the accreted terrains, this is starting about 200 million years ago. This is 120 million years ago, about 80, and then this is about 40 million years ago. So seafloor spreading in the middle of the Pacific Ocean, these are chunks of things that are broken apart by these spreading centers, and they start to migrate apart. As far as 200 million years ago, they were located north of Australia. 120 million years ago, these things are not quite halfway to Alaska, but they're on their way. In this spreading center, you see there are big chunks of rock that ultimately form Siberia. There are other chunks of rock that are ultimately going to form the Aleutians and part of Alaska. And here is a collision with other terrain along this boundary along here. 80 million years ago, they're crashing together and are still going against and being subducted into North America. So here it forms these transform faults and things of this super terrain on its way north to Alaska. So this is a displaced trains in western North America, starting with the Gulf of Alaska. This is going all through the British Columbia, and then down in here, here's the Franciscan and the Great Valley, and then over here into Nevada. Our area here is that this is the terrains in the western metamorphic belt. So you have in here, this is a can of Coors, in the center is a can of Dos Equis, and over here on the east side is Miller Lite. Three different distinct terrains, all crumpled up in area in here. So if you look at this, the foothills terrain are this gray area here. The northern Sierra terrain are the dots and dashes north of Quincy. The shoe fly complex is over the particular pen that just dotted these. These are on the eastern side of the foothills. The black dark blobs that you see down here are ultramafic rocks, and these are the major collision zones between the ocean plate and the continental plate. And at that particular zone, here the black areas here, these are fault zones with serpentine in them. Serpentine is an indicator that that was a fault collision zone. And so each of these major terrains are separated by major serpentine zones. Where do you find serpentine in Aurora County? What does serpentine look like?
Green.
It's our state rock. It's green, right. So, gee, you imagine if you're driving down Green Stone Road or Green Valley, you might find some serpentine. Absolutely. But there's a lot of other green rocks out there. But serpentine is only formed in this special environment. And it's an environment formed out of very high pressure and low temperature. There's a lot of seawater mixed in with it. And in that particular area, you can take the upper part of the crust, which is a rock we call peridotite. You can heat it up in that environment, add a little water to it, and you make serpentine out of it. So serpentine is that part of, so these serpentine belts run in what kind of a northwesterly direction. They mark a collision boundary between an ocean plate and a continental plate in a subductions area. So which direction was the ocean plate moving when you see these black oblong stripes?
West to east.
West to east.
East, northeast.
The ocean plate was going in this direction. The ocean plate was going in this direction. It then collided with the continental plate and subducted down. So a northwesterly trending serpentine zone is the contact between the ocean and the continent. In this particular area is in here. So you see that then 200 million years ago was the direction of the ocean plate. Now if you look at it today, if you look at the geologic map on the wall over here, and you'll see that the coast ranges are oriented in trend along that area there. The San Andreas Fault coming out of the Baja, California, comes up through Southern California, comes up through the Bay Area, and then goes diagonally northwesterly toward Alaska. The Pacific Plate is moving in a northwesterly direction, 90 degrees from the direction that the plate was moving when these serpentine zones were formed in these particular areas. So a lot of the regional geology can be interpreted from the orientation of terrains and the different rock systems. There is a correlation between the Klamath Mountains and the Sierra Nevada. The northern part of the Sierra Nevada is Mount Lassen. The southern part of the Klamath Mountains is the area around Redding, copper mines up in that area, things like this. The area in between is covered by what kind of rocks?
Okay.
This is Mount Lassen. There's Mount Shasta. This is the Mohawk Plateau. What kind of rocks do you find up there?
Volcano.
Volcanic. So volcanic flows from the Mohawk Plateau have flowed down into and covered up the extension of the Sierra Nevada and the Klamath Mountains. So the foothills of the Sierra Nevada and portions of the Klamath Mountains are identical in geology. They're just a kind of a northwesterly extension. I'll just skip these. This is when I taught my geology at California, we went into the different ages of formation of the Klamath Mountains. And this is the geologic ages and stuff. We have the different formations, the different colors representing times. This is a kind of an overall picture from, this is the Penryn Pluton up here near Auburn. Down in here is Mona Lake, and down below in this area here is Mariposa. So this is actually then a very great portion of Allegheny up in here. This portion right down through here is a central mineralized zone of the Sierra Nevada. And if you take a look at this, here is the Penryn Pluton. This is the one in Coloma. Here's the one in Somerset. There are different ages of these. The different colors in here, the different dates, 130, 140, 150, 200 million years old. These are all radioactive ages by radioactive decay of uranium and thorium and all these other radioactive minerals. But they have dated all these things. But if you take a look at this, you'll see most of the really major producing mines were along these seafloor sediment fault zones. And very close to that, you had an igneous intrusion activating the fluids and solutions. So the geology of this area kind of tells you a little bit about why the gold is here. Yeah.
So, George, with all this pushing going on, are the Sierras still growing?
The Sierras are raising in elevation, right. And
I haven't noticed.
about 20 centimeters a year.
About 3 beer cans.
Not too many years that they go up. And we'll talk about that in just a minute.
That's a lot.
Later on, some of the recent research will indicate that the Sierras today are a little lower than they were 100 million years ago. 100 million years ago, the average elevation of Southern Nevada was 17,000 feet elevation. So it was the highlands area, and the Sierras, what is now the Sierras, are intermediate on the way to the coast.
Did you slide in somewhere that this is the Allegheny orogeny? The Allegheny orogenic activity?
The Allegheny area is north of Grass Valley, Nevada City. This is 16 to 1 mile. We'll show you that here in just a minute. But this is the different geologic ages, just showing the correlation when you're looking at that. Now the environments of deposition of these accreted terrains, these are part of continental shelf areas. You had highlands areas, you had these deltas forming, river channels running through, continental shelf areas, abyssal plain slopes, turbidity currents running down through there. These are the things that were all, of course, accreted together, crumpled up, and then put into these subduction zones. So the rocks that we see here now, this is the origin of these particular rocks. It's easy to identify the rock when you find it and say, oh, that's a lithic greywacke. That's some of that strange terminology we use. But what was it originally? That was a coarse gravel and alluvial plain 200 million years ago, this type of thing. So we're trying to find out, what is the rock today, how did it form, and reconstruct what the environment. Some of the andesite formations of these turbidity currents are continental shelf, right, shallow shelves around the edge of the continent, streams and freshwater streams dumping this stuff in here, accumulate these muds then go up to the edge, and they don't have any strength, and so you have these massive mudslides or turbidity currents that went down onto the 6, 8, 9,000 feet elevation on the abyssal plain. And as it goes down, these turbidity deposits, then when this thing is rapidly moving, these particles, different sizes of silt, sand, clay, gravels, they're all different sizes randomly, but when that thing stops, boom, then these things settle on a solution. Of course, the particles go to the bottom, the finer